Hello everyone, good evening. Could you hear me? Okay, so we still have few minutes left. Let others also join and then we'll start. Okay. Okay, good evening all. Can you hear me? All of you? Hi. So where were we last class? Acha, have we discussed about moles? Okay, formula we have seen, three different formula. Okay, why we have discussed this, why 1 mole has 22.4 liter? Okay. Okay. Let's start. Okay. Yeah, I'll just quickly go through it. Okay. Just a second. We have discussed last class about the moles, the concept of moles we have discussed, and we have seen the formula of number of moles, which is and these formulas are in terms of mass, in terms of entities, in terms of volume, right? So the number of moles the formula we have seen is given mass divided by atomic or molecular mass. This is also defined as number of entities divided by Avogadro number. And it is also defined as the volume occupied by a gas divided by the molar volume. Molar volume is represented as Vm. Okay, this formula we have already seen. I'm just going through it, a quick revision of it. Okay, given mass by atomic mass is 1 mole, because we know the atomic mass is the mass of 1 mole of an atom, right? Since 1 mole of an atom, the mass of that is the atomic mass. Hence, the number of moles is what? The given mass divided by atomic mass. So if atom is there, we'll write here atomic mass. If molecule is there, we'll write molecular mass. Okay, and that is how the formula is. Why this formula we have? Because we know this fact that atomic mass or molecular mass is the mass of 1 mole of an atom. 1 mole of atom or molecule. This is the relation we have, right? That's why the number of moles is given mass by molecular mass. Now this number of entities divided by Avogadro number, why this formula we have? Because we also know that 1 mole is nothing but any quantity, right? 1 mole is equals to any unit, right? So number of unit divided by Avogadro is nothing but the number of mole. Okay, so that's why we have this formula. Molar volume is what? Write down. Molar volume, write down. It is the volume occupied by 1 mole of a gas. Volume occupied by 1 mole of a gas. One more thing you see, this formula is true or correct at STP only. at STP, right? So we can only use this formula for gases at STP, right? NTP also we can say. NTP also we can take, 1 mole is 22.4 liter. That also we can take, okay? So molar volume is the volume occupied by 1 mole of gas. So molar volume is represented by Vm, and the value of Vm is 22.4 liter, or in ml we'll write it as 22,400 ml. This is the molar volume. Now, why the gas occupies these many volumes at STP? For this, you can write down the equation of state, right? So we have already discussed this equation of state. If any state we have to define for the gaseous species, we'll define this with the 3 variables, and those variables are pressure, volume, and temperature. So PV is equals to nRT, right? This is the equation of state we have. Now at STP, what we can write, at STP what happens, N is equals to, we have to take 1 mole, we have to find out the volume occupied by 1 mole of gas. So N is 1 we are taking, pressure is again 1 atmospheric, right? Temperature is 273 Kelvin. We always write temperature in Kelvin for this equation, right? And R value, we know R value is 0.0821 liter atm per mole Kelvin. Now, when you substitute all this value in order to find out volume V, then the expression is V is equals to 1 into 0.0821 into 273 divided by 1 atmospheric. When you solve this, you'll get 22.4 liter approximately, right? So since this is the volume of 1 mole at STP, right? That's why what we can write 22.4 liter is equivalent to 1 mole of any gas. But this relation is true only at STP. The value of R is 0.0821 only. I have given you this value, no? The universal gas constant R is 8.314, it is joule per mole Kelvin, and 0.0821 atm liter per mole Kelvin. Since volume we need to find out in liter, that's why we have used this one. See, when we write down the equation of state, right? PV is equals to nRT. The PV is equals to nRT. We have, we can derive this also with the help of various gas law, right? We can derive this, and when you derive this, you'll find that for a given number of moles, right, the PV by T, PV divided by T, this term is directly proportional to the amount of gas which is present, right? Amount of gas which is present. Right? So when you remove that proportionality sign, okay, then you have to provide a constant over there. That constant is with the derivation we'll do in states of matter, not now. Okay, that constant is the gas constant. Okay, R value. Okay, so R actually signifies that the ratio of pressure into volume and the amount of gas into its temperature is always a constant at a given state, right? So this is a constant term that we use. We have various constant, like when you write down force, gravitational force, G m1 m2 by r square. That G is what? G is the gravitational constant, because the force is observed to be directly proportional to the product of mass and inversely proportional to the square of the distance between the two masses. Yeah, we cannot use 8. You can use 8.314 also, but then you have to convert this into ATM liter, because volume must be in liter. No, both are, see, joule you can convert in ATM per liter, ATM liter always. Both are energy only. Joule is energy, ATM liter is also energy. So we can convert this into this always, right? Since volume you have to find out in liter, that's why I have taken this. You can see this. If you check the dimension over here, what is this one? It is pressure, right? So if I write down all the dimension of all the terms here, you see what we'll get. Dimension, if you write down, you'll get this. You see this. Pressure is 1 atmospheric, so it is ATM into, this is liter ATM per mole Kelvin. R unit is this, into temperature is in Kelvin divided by pressure, right? Okay, this is mole. By mistake, I have written this as ATM. This is mole, right? Because 1 mole we have, no? So this is 1 mole. Mole into this divided by, this is pressure, so ATM. So now when you solve this, you see this mole and mole gets cancelled. Kelvin gets cancelled. ATM gets cancelled. So what we are getting? We are getting liter here. That's why directly we get volume in liter. And hence we're using this particular. So in gaseous state, we'll use this. R value is 8.314. We use this R value in thermodynamics, where we have to deal with energy, right? Mainly we use this value in thermodynamics. Got it? Clear? Understood? So molar volume is 22.4 liter, okay? And 22.4 liter is equivalent to 1 mole of any gas at STP. Okay? All of you understood? Yes, it is. Yes, it is. Correct, mother. Okay, now you see, based on this, we'll see few problems here, you see. The first question is, I'll write down. All of you must write down the question. Out of 5 moles of CO2, 10 to the power 23 molecules have been removed. Find out the moles of CO2 left. Moles of CO2 left. Acha, we have done this question, so let it be. We won't do this. Have we done this one? So what was the answer for this question? Could you tell me? 4.83. Okay, so we have done this question. The answer is 4.83. So let it be. We won't do this again. Correct. Another question you see. Have we done out of 5 moles of ozone? This one I've done. Out of 5 moles of ozone, Acha. Write down, out of 5 moles of ozone, ozone, 3 moles of O2 are removed, removed. Calculate the number of moles of oxygen atom left. Try this. Okay, 9 moles you are getting. Let others also solve. Okay, fine. So 9 moles is correct. 9 moles of oxygen atom left. Okay. So how do we do this? 5 moles of O3. You see this 5 moles of ozone. Ozone is O3, has 15 moles of oxygen atom because 1 mole has 3. So 5 mole has 15. And out of this 15 moles, 3 moles of O2 has been removed. Right? So 15 moles of oxygen atom, 3 moles of O2 is equals to 6 moles of oxygen atom. So out of 5 moles, 6 moles has been removed. So what is the number of moles left? 5 minus 6, 9 moles of O atom left. If they ask you the number of oxygen atom present, the number of oxygen atom left, what is the answer? 9 into Na, because it is mole. So number of oxygen atom will be what? 9 NaO atom left. This is the answer here. Okay, fine. So I guess all of you have done this. We'll see some more questions onto this, but before that, we'll discuss 2 terms here. Write down the next one. It is gram atomic mass. What is a gram atomic mass? And you will say it is a mass expressed in gram. It is the mass of an atom expressed in gram. Yes. Tell me, what is the gram atomic mass? Okay, fine. So like in 10th grade, you must have studied this term. And in 10th grade, the definition is given when the mass of an atom expressed in gram, it becomes the gram atomic mass. Yes or no? That is also definition given, right? But we won't use that definition now. Okay, gram atomic mass is defined as, most of you have written the definition, that is correct, defined as it is a mass of 1 mole of an atom. So write down gram atomic mass. It is the mass of 1 mole of an atom. This is the definition of gram atomic mass. So we know the mass of one atom. Suppose I am taking carbon, for example, I am taking carbon. What is the atomic mass of carbon? Atomic mass of carbon is what? It is 12, right? The atomic mass of carbon is 12 AMU, right? Don't write 12 gram, 12 AMU, right? Now the absolute mass of carbon is what? When you convert this AMU into gram, that is 1.66 into 10 to the power minus 24 gram, because 1 AMU is equals to 1.66 into 10 to the power minus 24 gram. Okay, this is the mass of one atom in gram, correct? Mass of one atom in gram. So what is the mass of 1 mole of an atom? So mass of 1 mole of an atom mass of Na atom, which is nothing but the 1 moles of an atom, is equals to 12 into 1.66 10 to the power minus 24 into 6.022 into 10 to the power 23 Avogadro number, right? So when you do this, the product here, this becomes what? 1. This product is coming out to be 1. And hence, this 12 AMU becomes 12 gram here. Okay, 12 AMU becomes 12 gram. Yeah, we are taking the example of carbon only, right? Since this gram atomic mass is coming as 12 gram, atomic mass is 12 AMU. That's why the definition they have given in 10th standard, that when atomic mass expressed in gram, it becomes gram atomic mass. You have to keep that in mind. The gram atomic mass is the mass of Na atoms. Atomic mass is the mass of one atom. Atomic mass, if I ask you, your answer should be in AMU. 12 AMU, 14 AMU, 16 AMU, like that. But gram atomic mass must be in gram, 12 gram, 14 gram, 16 gram, like that. But to solve the questions, we consider both as same. Means, like, usually what we say, what is the atomic mass of carbon? We say 12 gram. We don't write 12 AMU, right? So for solving that question, you can take it as similar, but there is small difference between the two. Okay, copy this down. Okay, write on one note. Gram atomic mass or gram atom, both are same thing. Write down gram atomic mass or gram atom of every element, gram atomic mass or gram atom of every element consists equal number of atom consist equal number of atom, and that atom is what? What is that number? Sorry, equal number of atom, and what is that number? That number is Avogadro number. Write down, consists of equal number of atom, and that number is nothing but the Avogadro number. Write it down. Yes, Anurag.
Can you repeat?
Okay, understood?
Sir, can you repeat the statement?
Gram atomic mass or gram atom, both are same thing first of all. Okay, so gram atomic mass or gram atom of any element of every element consist the same number of atoms and this number is equals to the Avogadro number. Correct? So you see here, if I take 14 gram of nitrogen, 14 gram of nitrogen, how many nitrogen atom we have? Na nitrogen atom, because its atomic mass is 14. If you take 16 gram of oxygen, then again Na oxygen atom, and so on. Right? So if atom is different, but if you're taking atomic mass of those atoms, then all these atoms will have, all these elements we have equal number of atoms, and that number is the Avogadro number. Clear, all of you? Right. And again, you see one more thing, that atomic mass is nothing but 1 mole. So if atomic mass contains Na nitrogen atom, so hence 1 mole also contains Na nitrogen atom or oxygen atom or any other atom. Right? That means we can find out the same thing, that 1 mole is nothing but Avogadro number. Okay. Now based on this only, we have another term and exactly same. The only difference is we are not taking atom, but we are taking molecules here, right? So write down this next term, gram molecular mass. Gram molecular mass, write down. It is the mass of Na molecules of a compound. Exactly same, only difference is we are taking molecules but not atoms. Okay, it is a mass of Na molecules of any compound. For example, suppose I took H2SO4. Could you tell me the molecular mass of this? The molecular mass is 2 into 1 plus 32 sulfur and 16 into 4. This value is 98 gram. So 98 AMU, not gram. Okay, because it is molecular mass, so 98 AMU. Now again, if you convert this AMU into gram, which is the absolute mass of it, we'll have 98 into 1.66 10 to the power minus 24 gram, the absolute mass. So mass in gram, we call it as absolute mass. So this is the absolute mass of H2SO4. Right? Further, if you calculate the gram molecular mass, it is the mass of any such molecule. So 98 into 1.66 10 to the power minus 24 into Na. Again, this product is 1, so this becomes 98 gram. And that's why it is again says that when the mass of a molecule expressed in gram, it becomes the gram molecular mass. Clear? Any doubt? Atomic mass we always expressed in gram, right? Hydrogen atomic mass is 1 AMU. Sulfur atomic mass is 632 AMU, atomic mass unit. Because if you write down in gram, you have to write down this huge number. You see this? You have to write down this huge number. So to maintain the database in a easier manner, we have defined AMU. And hence, obviously, this 98 AMU is easier to write than 98 into 10 to the power minus 24 gram. So that's why we have defined AMU, and we express atomic mass in AMU only. Clear? The value is close to 1, so we can take it as 1. Okay, understood all of you guys? You can type CLR quickly. Okay. Now we'll see some questions based on this. See. I want you to solve these questions, okay, and send me the answer in a one shot, right? Don't like 13A, 14B like that. Solve all first and then send me the answer in a one shot. All of you. Nothing, like when most of you finished, we'll start solving it. Okay, first one. Anurag, you try this. Okay, whatever information you have regarding the reaction, you try this once. Okay, I'll discuss it once all of you have finished once. Magnesium bicarbonate, it converts into what? Carbonate. Yes, correct. Arnav. Magnesium bicarbonate converts into carbonate, water, and CO2. Now you try. Arnav, you solve all and then you can post your answer. Shashwat, what about 13, 14, 15, 16? That you haven't done? Okay, Pranav has done. Are you done? Shall we start? Let me know if you are still trying. Okay, okay, try. Okay. Arnav is done. Hariharan is done. Okay. Akash is done. Okay. Fine, we'll start then. Okay. See, the first question we have, the volume of CO2, carbon dioxide gas evolve at STP by heating 7.3 gram of MgHCO3. Okay. To solve this question, you should know the reaction. That information you should have. Okay. And that is what the problem with chemistry. To solve such questions, you should have some prior information. If you do not know that, you could not do it. Right? You won't be able to do it if you do not know that particular information. Correct. So here, what information is required? The information required here is that how this MgHCO3, that is magnesium bicarbonate, not always, like this kind of reaction you should know. Okay, you cannot be sure with it that they will give the reaction always, Siddhant. Okay, so you should know the reactions. So to solve this question, you should know this reaction. Otherwise, you know the method, how to solve. But since you do not know the reaction, you could not do anything to this. Right? It forms carbonate MgCO3 plus it forms water and CO2 gas evolved into this one. CO2. Okay. Now you see the reaction is balanced because once you know the reaction, you can balance it. And then you can find out the mole ratio. But the reaction is already balanced, if you see. So you don't have to do anything. So what we can say, 1 mole of this, because we have 1 mole of MgHCO3. You see this coefficient is 1 here. This is also 1. This is also 1. This is also 1. Okay. So these numbers we call it as stoichiometric coefficient. Stoichiometric coefficient. Okay, these numbers are stoichiometric coefficient. Okay, and we can say from this reaction we can say that 1 mole of magnesium bicarbonate, 1 mole of MgHCO3 whole twice gives 1 mole of CO2. That is the use of this equation. If it is 2 CO2 here in balanced reaction, then 1 mole gives 2. Right? That is why the reaction is important here. Now we know the mass of MgHCO3. So what is the number of moles here for MgHCO3? The number of moles is given mass 7.3 divided by molecular mass of MgHCO3. Anyone? It is 146. Okay, 146. So that would be 1 by 20, that is 0.05 moles. Right, so we'll get same number of moles for CO2 also, because 1 moles of this gives 1 moles of CO2. These many moles gives these many moles of CO2. But we need to find out the volume of this. So these many moles is equals to, we can write down the formula, and the formula we have here, the volume occupied by the gas divided by the volume, molar volume, right, which is 22.4 or this ml, in ml if I write them, because the options are in ml. So when you solve this, the volume of CO2 here is 1120 ml of it. Okay, this is the answer, the first one, option B. Okay, next question number 14. What is the answer? Question number 14. All of you have got A? Okay. Zinc on reaction with an acid. So what is the reaction we can have here? Zn plus H2SO4. So this gives ZnSO4 plus H2. Gas evolves, right? Zinc atomic weight is given to produce 2 to 4 ml of H2. So could you tell me a condition also? It is at STP, not mentioned here, but we have to take it as STP. Okay. The moles of H2 is what? It is 224 volume occupied divided by 22400, which is 0.01 mole. And since the reaction is balanced, right? So 0.01 mole of this, we need 0.01 mole of zinc, because equal moles we have, right? And this equals to mass divided by atomic mass of this. M is equals to 0.65. No doubt. So answer is A. Yes. With HCl also you get the same answer. Correct, Random? You got the same answer, no? Whatever acid you take, you'll get the same answer. Yes. Now, 15th one, the number of atoms in 4.25 gram of ammonia. Okay, so we have 4.25 gram of ammonia. So number of moles, we have this one, 15th one. The number of moles of ammonia is 4.25 grams, so mass divided by the molecular mass of NH3. So this is 0.25 moles. Okay, so 1 mole is equals to Na atom. Right? So the number of atom is equals to 0.25 into Na, which approximately I am taking 6 into 10 to the power 23. So it is 1.5 into 10 to the power 23 atoms we have. Achha, they have asked number of atoms. Just let me check. What is the question? The question is, achha, the number of atoms. Fine, then not an issue. The number of atoms, what we'll do? See, one molecule has how many atoms? One molecule has 4 atoms here, right? So we have, it is not atom actually. This value that we get here, this should be the number of molecules. Okay, so this is the number of molecules. These many molecules we get. Okay, now one molecule has 4 atoms, 3 nitrogen, 3 hydrogen and 1 nitrogen, right? So one molecule has 4 atoms, right? 3 for hydrogen atom and 1 for nitrogen atom. So these many molecules. So total number of atoms is equals to 4 into 1.5 into 10 to the power 23. So that would be 6 into 10 to the power 23. This is the answer we get. Okay, 1 mole of an atom. Correct. 15th one is this. Okay. The 16th one, the question is what? The number of molecules in 4.25 gram of mole. It's the same thing, no? Number of molecule is, just now we have done, number of molecule is 1.5 into 10 to the power 23. Just now we have done. The weight of single atom of oxygen. What is the weight of single atom of oxygen? We know the weight of Na atom of oxygen, 17th one. The weight of Na atom of oxygen is 6.022. Oh, sorry. Weight of Na atom is atomic mass. For oxygen, it is 16 gram. Right? So Na atoms means 6 into 10 to the power 23 approximately I am taking. It is equivalent to 16 gram. So one atom, the mass is what? 16 by 6 into 10 to the power minus 23. So 2 point what? 2.66 into 10 to the power minus 23. It is the mass we have. Right, so we'll approximately get C here. Is it clear? Understood?
Sir?
Yeah.
So for the 15th one, sir, isn't the Avogadro's number same for the number of atoms and the number of molecules? Like,
No. If molecule is monoatomic, then we can say.
so if the molecule has more than one atom present,
More
then
than one atom, then see NH3,
then
the example we have, right? So in one molecule of NH3, how many atoms we have? We have 3 hydrogen atom and 1 nitrogen atom. So there are 4 atoms present in one molecule. 1:4 ratio is there. Molecules and atom, 1:4 ratio. So number of molecules, if it is 10, then the number of atoms will be 40.
Okay.
Like that. Okay. See, for approximation, by looking at the option, you will understand. Okay. So don't worry about that. If your calculation is getting easy, like quite easy, if you take that approximation, you should take that. But when you have to take, when you solve some questions, you do some practice, you will get the idea that when you have to take the approximation, right? So, and by looking at the option also you can take, you will have the idea that, okay, option is this, then by taking this approximation, we can do this question easily. Correct? Okay. Okay. Sometimes what happens, suppose we have, I'll take the same example here. The question is, we have 42.5 gram of NH3 molecule. We have to find out the number of electrons present into this. Find out the number of electrons. Try this. 42.5 gram of NH3. What is the number of electrons present into this? 6 into 10 to the power 24. Okay. Let others also solve. Okay, done. See, you're getting different answers, all of you. See, what we need to find out, we need to find out the number of electrons, correct? So the number of electrons, could you tell me how many electrons present in one molecule of NH3? How many electrons we have into this one? Atomic number of nitrogen is what? 7, right? So 7 plus 3, we have 10 electrons into this. So if we know the number of electrons in one molecule, suppose we have 10 molecules, how many electrons? 100. Suppose we have 100 molecules, how many electrons? 1000. Correct. So basically the question is reduced to what? The question is reduced to the number of molecules of NH3. If you find out the number of molecules of NH3, that number of molecules into the electrons present in one molecule is the answer. Understood? Got it? Right? So in 42.5 gram, the number of moles is what, first of all? Divided by 17. So this will be 2.5 moles. And 2.5 moles is equals to how many molecules? 2.5 into Na molecules. Right? 2.5 into Na molecules. But one molecule has 10 electrons. Right? So 2.5 into Na molecules will have this into 10. That is 25 into Na electrons. And when you solve this, 25 into 6 into 10 to the power 23, so that approximately you get 10 to the power 25 electrons. Is it clear? Right, so if they ask you
shouldn't
number
it be
of
1.5 into 10 to the power 25?
Acha, 1.5. So no, it's 25. No, so it is 15 into 10 to the power 24. So that I'll correct it as, wait, oh, I thought it is 100. That's why I wrote. Anyways, so 150 we got, right? So 150, so it is 1.5 into 10 to the power 25. Is it right? Electrons. Okay, 1.5 into 10 to the 25 electrons. Okay, so sometimes what happens, they'll ask you the question regarding the number of electrons. You don't have to do anything because you know the atomic number is nothing but the number of electrons, right? So just you need to add atomic number of the atoms present in the molecule. That will be the number of electrons present in one molecule, right? Then based on the data given, You have moles, then we have molecules. So one molecule has this many electrons. The given number of molecules has how many electrons? Just unitary methods you have to apply. Right, all of you understood? Okay. Okay, one more question you see, the other type of question we have. We have suppose 7 gram of N3 minus ion. 7 gram of N3 minus ion. In this again, you need to find out the number of electrons. Number of electrons. Try this. Okay, done. See, it is the ion of nitrogen. So atomic mass will take that of nitrogen only. See, first of all, you tell me the number of electrons in N3 minus ion. In this we have 10 electrons. 3 minus means that 3 electron you have added onto this atom. So we have nitrogen neutral atom initially present and 3 electrons you have added onto this. And then you get this N3 minus. So 7 electron it already has, 3 you have added, so it got 10 electrons on this. So one ion has 10 electrons. So we need to find out how many ions, right? And for that, what we have to do? Number of moles, first of all, we'll find out. So number of moles is 7 divided by 14. That is 0.5 moles. 0.5 moles is equals to 0.5 into Na ions. And this one ion has 10. So this many ions have 5 into Na electrons. 5 into Na electrons. Yes, you can multiply this, you'll get the answer, but the answer will be 5 into Na. Understood? So if they ask you to find out the number of electrons, you can easily find out this. This question you see, try this one. Finished. Done. No, room temperature is around 20 degrees Celsius. That if you convert into Kelvin, it will be around 293 Kelvin. Around 20 degrees Celsius is the room temperature. Okay. How many of you have done 23rd one? Okay. Let's start the discussion. 23rd one is easy. Even 24th one is also easy, but you need to know a bit of information again about it. Question number 23rd, you see, it says, what is the volume of oxygen at STP required for complete combustion of CH4? So again, you should know this reaction. And what is the reaction? Combustion reaction means reaction with atmospheric oxygen and hydrocarbon. All hydrocarbon on complete combustion gives you CO2 gas and H2O liquid. This is the reaction we have. And then we'll balance the reaction. 2H2O. So 2 plus 2, 4 oxygen, so 2 oxygen. Correct. So what we can say, 1 mole of CH4 gives 1 mole of CO2. We can say that 1 mole of CH4 gives 1 mole of CO2. Even we can also say that 1 mole of CH4, 1 mole of CH4 combines with 2 mole of O2 and forms 1 mole of CO2 gas. Liquid we do not compare. We can't compare liquid. Only gas we can compare. Okay. You see 32 gram of CH4 is given. It means the given number of moles is what? 2 moles. 16 gram is what? 1 mole. So 32 gram is 2 mole. It is given in the question. So 2 moles should combine with 4 moles of O2 and gives 2 moles of CO2. Right? Now, you need to find out the volume in liter of oxygen, right? Which is required for the complete combustion of this. So for the complete combustion, it requires 4 moles. That is the number of moles we need to find out. 4 moles of oxygen required for complete combustion. So 4 moles is equals to what volume? 4 into 22.4, which is 89.6. Easy. Easy, yeah. If you want to give it a try on 24th, I will give you a hint here. You want to take that hint? You want to try it again, or should I solve it? You take the density of water into consideration. What is the density of water? 1000 what? Unit, you tell me. Density of water is 1000 kg per meter cube. Approximately, you can assume 1000 kg per meter cube. Are you close? Okay, let's see. Twenty-fourth one. Density of water is 1000 kg per meter cube. This you should memorize. Okay, which we can further write it as 10 to the power 6 gram divided by meter cube is what? 1000 liter, and 1000 liter is 10 to the power 6 ml. 10 to the power 6 ml. So what we can write, 1 gram per ml is its density, right? So what is the molecular mass of water? 18. And molecular mass is equivalent to what? 1 mole. So we know what? We know the volume of 1 drop of water, right? So if we find out what is the volume of 1 mole of water, right? If we find out the volume of 1 mole of water, then we can say 1 mole water means Na water molecule. Na water molecule has volume this. So for this given volume, what is the number of water molecule we should have? Are you getting it? So what I'm telling you, that you try to find out the volume of 1 mole of water molecule. Okay, let's try this. So I have taken this term. So if I multiply 18 in the numerator and denominator, what we get? 18 gram. And why 18? I'll tell you. 18 gram divided by 18 ml. 18 gram of water. You see, 18 gram of water is equals to 1 mole. Hence, what we can say, the volume of 1 mole of water is what? Can you tell me? Volume of 1 mole of water is what? Could you tell me the volume of 1 mole of water? Volume of 1 mole of water is what? You see, 18 gram per 18 ml. It means the volume of 1 mole of water is 18 ml. Yes. So we can say the volume of 1 mole is 18 ml, and that is what we need to find out. Because we know 1 mole is equals to Na molecules, means Na molecules of water has what volume? Na molecules of water has volume that is 18 ml. So 18 ml, the number of molecule is this. For these many mLs, what is the number of molecules? So I'll write down this unitary method. So number of molecules for 18 ml is equals to 6.022 into 10 to the power 23 molecules. So 1 ml is equals to 6.022 10 to the power 23 by 18. And what is the volume given? Could you tell me the volume given? 0.0018, right? I'm not very sure. Is it the volume 0.0018? Yeah, okay. 0.0018, 6.022 into 10 to the power 23 divided by 18 into 0.0018. So when we solve this, we'll get 18 gets cancelled, n to the power 4. So it will be 6.022 10 to the power 19 water molecules present in this volume. Easy. So what information you should have? What information you should had for this kind of question? The density of water. Okay. Usually what happens, density of water they do not give in the question because they assume that you know the density of water. I'll explain that again, Arnav, just a second. Right, what point I'm trying to make, that you should know the density of water. If any other solvent is given, then the density will be given in the question. Okay, but for water, what they assume that you know the density of water. So this thing you have to keep in mind. See what I said, the density is the density of water, we know it is 1000 kg per meter cube. Now if you convert this into gram per ml, you'll get 1 gram per ml. Anyone has doubt in this? How do we get gram per ml? Anyone has doubt into this? No? Yes or no, guys? So if 1 gram per ml is the density, then if I multiply this by 18, why I am taking 18 here? Because 18 is the atomic mass of water, molecular mass of water. So 18 divided by numerator and denominator multiplied by, so we'll get 18 gram per 18 ml. This means what? That 18 gram of water occupies this volume, this ml of volume, 18 ml of volume. Right? 18 gram occupies 18 ml. That is what the meaning we have, right? So 18 gram is equals to what? We know 18 gram is equals to 1 mole, and 1 mole is equals to Na molecules. So it means what? That Na molecules, the volume is 18 ml. So 1 molecule, what is the volume? We can find out. Or 1 ml, what is the number of molecules? We can find out, and then the given number of volume. Because in the question it says, see, what is the question we have? What is the question we have? That this ml is equals to what number of molecules we have. So we find out for 1, then this will be multiplied by that, no? See what I have done here. 1 ml, this is the molecules. These many mLs, what is the molecule? This into this. Clear? No doubt? Okay. Now let us understand the next concept here. Next concept here, write down Avogadro's law. Avogadro's law. Write down. First of all, it is applicable only for gas. Only for gas. Condition is pressure and temperature constant. We should have constant pressure and temperature. Correct? Write down the statement. For a given amount of gas, for a given amount of gas, for a given amount of gas, the volume occupied by the gas is directly proportional to the number of moles of the gas present is directly proportional to the number of the moles of the gas present at constant temperature and pressure. At constant temperature and pressure. Done? Again, I am repeating this. For a given amount of gas, comma, the volume occupied by the gas is directly proportional to the number of moles of the gas present at constant temperature and pressure. At constant temperature and pressure. Okay, this is Avogadro's law. So two things you have to keep in mind. One is it is applicable only for gases, and the condition is the pressure and temperature must be constant. Okay, let's see. Yeah, a little bit I have discussed, but based on this, we'll see numericals now. Okay, you see we have the ideal gas equation, which is PV is equals to nRT. PV is equals to nRT. Now the condition for Avogadro's law is what? The pressure and temperature is constant. R is already a constant. So V is directly proportional to N. That is what the statement we have. Volume and number of moles are directly proportional. Okay. So for the same gas, if you take two different amounts, right? Two different amounts of a gas at the same condition. If we have two different amount of a gas at same condition, means same temperature and pressure, then what we can write, the volume occupied by the gases must be have the same ratio, and that in the ratio of their number of moles. Is this correct? Right? Two different amounts, suppose N1, N2 you have taken at the same condition. So N1 will occupy certain volume, N2 will also occupy certain volume. So the ratio of V by N will be a constant. So V1 by N1 is equals to V2 by N2. Correct? No doubt. Now you see in this one, I have taken the same gas. Keep this in mind. If I have taken the same gas, then we can further write this as V1 by M1 is equals to V2 by M2. That is also we can write. Where M1 and M2 are the masses. Because this number of moles, if you convert this into mass, you'll get this relation. Suppose number of moles, if you place here in terms of mass, so V1 by M1 divided by molecular mass of the gas, V2 by M2 divided by molecular mass of the gas. Since the gas is same, so molecular mass will also be same. This will get cancelled, and hence we get this relation. Yes. If the temperature and pressure is same, we can apply this for any gases, all gases. Yes, different amount of gas, but the condition is what? PT, P and T must be same. then we can apply. Okay, so further you see in this we have two conclusions we can make out of it, and you keep this in mind, this one, V1 by N1 is equals to V2 by N2. So suppose I have taken equal volume of two gases at the same condition. Case 1, write down, case 1, equal volume of two gas at similar condition. Means pressure and temperature is same. So when the volume is equal, with this relation what we can write, they must have equal number of moles. Equal moles, and equal moles means what? Equal number of molecules. Right? Equal number of molecules, can I say that? Tell me guys. Equal volume, so equal number of moles, equal number of moles, so equal number of molecules. Okay, but the second case is what? Suppose the two gases will have equal volume, V1 is equals to V2, and this volume is equals to the molar volume. Then what we can conclude from this information? Could you tell me? If the volume is equals to molar volume, it means they must have 1 mole, right? So gases must have 1 mole. So 1 mole is equals to how many molecules? At STP, correct. 1 mole is equals to how many molecules? Na molecules, right? Hence what we can say, if the gases occupy molar volume, right? And molar volume means we have STP, standard temperature pressure. If the volume of the gas is occupied is equals to the molar volume, it means they must have equal number of moles, and that mole is nothing but 1 mole, and 1 mole of gas occupies Na molecules. So when we compare this volume and molecules, what we can say, if the gases has equal volume and the volume is equals to the molar volume, then all gases will have equal number of molecules, and that number is nothing but Avogadro number. Can I say that? Okay, so this statement you write down, all molar volume of all gases will have, all molar volume of all gases will have equal number of molecules, and this number is equals to the Avogadro number. Okay, so what did I say? If the volume is equals to the molar volume, so molar volume means the number of moles is 1, and since 1 mole we have, so 1 mole is equals to Na molecules. Hence we can say, if the volume of the gases is equals to molar volume, then they must have equal number of molecules, and that molecule is what? Is Avogadro number. Yes, we can say Vm is equals to 22.4 liter at STP. Did you understand this? Clear, no? ठीक. Now you see one question based on this concept. And I want you to write down the question. All of you. Write down the question. From 44.8 liter of NH3 gas, I'll just write down the data here. You write down the statement. We have NH3 gas and we have 44.8 liter of it. So from 44.8 liter of NH3 gas, 5 into 10 to the power 23 molecules of NH3 are removed. 5 into 23 molecules of NH3. Molecules removed. Calculate the volume of NH3, V of NH3 left at STP. Options are given. 49.2 liter, 'Yes, Madhav. Wait. Okay. We'll have the polling thing next week. Okay, we'll see that. You know, we have a quiz next week. All of you know, right? We have a quiz next week. Also, okay, so get prepared for that. You do not know, Nurag. Why? You were not there in the class? Your classmates know about it. Topics like you will have for physics, chemistry, and maths. So whatever we have done in chemistry, that will be the the question you will get on that. Similar thing I think you'll have for physics and maths also. No, next week you do not have regular class, but you will have a quiz. Yes. You see, first of all, this question, you don't need to solve this question. Okay. But how to solve this question, that also we'll discuss. Okay, the method we have. But you see, the three options that we have, right? Ideally, what happens? What should happen here? Since we are removing this molecules, so volume of NH3 should decrease, right? Should decrease from the original volume, right? So it cannot increase because we are removing the uh, molecules from this. And that you see the options, we have only one option which has volume lesser than the given volume in the question. Yes, Madhav, correct. Okay, that's why the answer is B. You can directly go for this answer. You don't need to solve this question. So this kind of question you will get in the exam or test where you can eliminate options and get the answer. So options are always half of the information. Okay, both way you should think. Yeah, I'll the shortcut is this only, Arnav. What I said, that initial volume is this, and you have removed some molecule. So the final volume should be what? Should be lesser than this 44.8, right? And you see the options, all the options, there's only one option we have here where the volume is lesser than this. Then you have to go for this only, B. There's no other way. There's no other options possible. Even if the exact value is not 26.13, suppose the exact value you are getting, you're calculating from the method, and you are getting 20 liter, then also you should go for this because that is the only possible answer we have. Yes, that way also we can do. That is the method, Arnav, we have. That way also we can do. But when we have this kind of options, you can eliminate those and save your time. Right? Another thing, how do we do this? Initially, if I ask you, what is the number of moles? We have 2 moles initially present. And what is the number of moles removed? That is 5 by 6. 5 by 6, you see, it is almost close to 1, right? Can we say that? Right, it is close to 1. Just to find out the answer. Means half mole you have been removed. Means the volume of which is left, it is closer to half of this value. Right, half of this value is what? Around 22.5 you are getting. So more than 22.5 is this only. This is the closest option we have. Got it, no? So the actual calculation is what? V1 is given, I'll just quickly write down this. V1 is 44.8 liter. N1 is 2 mole. N2 is 2 minus 5 by 6. That would be 7 by 6. V2 we need to find out. Condition is given at STP. So P and T is are constant here. So we can apply Avogadro's law. V1 by N1 is equals to V2 by N2. So from this, if you find out V2, it is equals to V1 is 44.8, V2 is 7 by, sorry, V2, we need to find out, N2 is 7 by 6, and N1 is 2. So when you solve this, approximately you'll get 26.13 or 20. 44.8 liter is how many moles? This divided by 22.4 at STP. Bharat. Got it? No doubt. Okay. Next, we'll see the concept of density. Density is represented by a small d or a letter rho. This symbol is rho, Greek letter rho. It is density, right? It is the ratio of what? Ratio of mass by volume. So unit of density, we can write it is kg per meter cube, or we can write gram per ml, or we can write gram per cc. Yes. Gram per cc. So these relations you should know. 1 ml is 1 cubic centimeter. 1 ml is 1 cubic centimeter. Okay. Now, 1 kg per meter cube, if you convert this into gram per ml, you will get 1 kg per meter cube. One more relation you can write here. 1 meter cube is equals to 1000 liter. This also you should know. And 1 liter is 1000 ml, right? You can do that. So 1 kg per meter cube, when you substitute all the value, you'll get 10 to the power minus 3 gram per ml. Okay. Now, there's a term, we call it as relative density. Relative density. Relative density means what? Yeah, it has no unit, and it is defined, the density of one substance defined with respect to another, right? So relative density, suppose if I define water, density of water with respect to air, so what we'll write? We'll write absolute density of water divided by the absolute density of air. This we call it as relative density, the density of water with respect to air. Okay. And since numerator and denominator, we have density only, so it has no unit. It is unitless, just a number. Similarly, with this concept, we also define another term, and that we call it as vapor density. Write down vapor density, VD. Write down, it is the density, it is the density of a gas. It is the density of a gas with respect to density of a gas with respect to the density of hydrogen gas. Okay, density of a gas with respect to the density of hydrogen gas, right? So any gas, if the density of gas you define with respect to the density of hydrogen gas, it gives you the vapor density of that gas. Okay. Why this is important? Because sometimes in the question, they won't mention the gas which is present there, right? Or there will be mixture of gases whose vapor density will be given. Mixture of gases whose vapor density will be given. So if you have to find out the molecular mass of that gaseous mixture whose vapor density is known, then how do we do that? Okay, how do we find out the vapor density, sorry, the molecular mass of a gas whose vapor density is given, right? So that's why we should understand the relation of vapor density and the molecular mass of a gas. Understood? So we have a formula. I can give you the formula directly here, but I will derive this. It's not a big deal. Just 2-3 steps we have. We can derive this easily. Okay, so that you can memorize it easily, and if you forget it into the exam, you can derive it at the same time. Okay, it won't take much time. Okay, so we have this equation, and what is this equation? You tell me. PV is equals to nRT. The equation of ideal equation of gas. N is nothing but mole, that is mass by molecular mass of the gas, into RT. Now this mass by volume is what? If I take this molecular mass this side and volume this side, it becomes what? Density. Are you there? Correct. It becomes density. So what is this formula we get? You see, we'll write here P into molecular mass of the gas is equals to the given mass divided by the volume into RT. So this term is what? Mass by volume is nothing but density. So this is D. So density is equals to what we get? P into molecular mass of the gas divided by RT. No confusion? Okay, so this is the formula of density, right? Now the vapor density, like I said, it is defined as VD is equals to the absolute density of a gas, and when we take the ratio of absolute density of a gas and absolute density of hydrogen gas, H2 gas. This is the vapor density definition we have. Means whenever we define the density of a gas with respect to hydrogen gas, it becomes the vapor density. Correct? Now you see, absolute density of a gas, with the help of this formula, we can write what? P into molecular mass of the gas divided by RT, divided by, for hydrogen it is P molecular mass of H2 divided by RT. So what happens here? You see, this pressure and pressure gets cancelled, RT gets cancelled, and this becomes the molecular mass of the gas divided by 2, the molecular mass of hydrogen. Okay, hence we can write the molecular mass of any gas or the mixture of gas is equals to 2 into vapor density of the gaseous mixture or that gas. Easy? Just a second. We are finishing it off. We'll take a break. We are finishing it off. Just a second. Maximum 5 more minutes. We'll take a break then. Okay, so this formula we have done. There is one more formula, and we call it as average molecular mass. This we also use for the mixture of gases, but the gas must be non-reacting. Okay, a mixture of non-reacting gases. Means suppose we have 2-3 gases, non-reacting gases. I'll show you, Shashwat. We'll see some problems based on this. Okay, let me do this first. Sometime, like spare few minutes with me. Okay, we'll discuss one question on this. Average molecular mass means what? Suppose you have one gas given, right? So you can find out the molecular mass of that gas, CH4, NH3. Easily it is, you know, you can calculate that. But suppose we have mixture of gases, 2-3 gases are mixing together. Then how do we find out the molecular mass? Okay, because any calculation, moles and volume calculation, if you have to do, so for that molecular mass must be required, right? That's why molecular mass is important, and we need to find out the molecular mass. So when we have mixture of gases, then how do we do? In that case, we'll calculate the average molecular mass of the mixture. So what is this? Write down. It is defined as, write down. It is defined for the mixture of non-reacting gases. Suppose we have a mixture of gas here, 3 gases I am taking, G1, G2 and G3. Mixture of this gas, it is defined for the mixture of non-reacting gases, you write down. And these 3 gases, what I am assuming that these 3 gases are reacting. Non-reacting, sorry. Non-reacting gases. Okay, the gases must be non-reacting. Sometimes you'll get some example, get some questions in which you feel like, okay, these 2 gases can react with each other. But whenever you have concept of vapor density and mixture of gases, you have to assume that the gases are non-reacting. Otherwise, the question is not possible. You cannot solve those questions. Okay. Why you have to assume? Because we already know this fact that for any reactions, we must have minimum amount of energy, or the condition of reaction must be there. Yes, guys? We have discussed this first class. You remember that carbon oxygen combustion reaction? We have discussed that, right? So for any reaction, we must have the condition for that reaction must be fulfilled. If that reaction, that condition is not there, reaction is not possible. So whenever you have mixture of gases plus vapor density is mentioned there, then what happens? You have to consider that the gases are non-reacting, basically. Correct? Non-reacting gases. So if this G1 has, suppose M1 mass, and capital M1 is the molecular mass. So what I am assuming is small m is the mass and capital M is the molecular mass. Okay. So the average molecular mass, that is M average defines as the total mass of the gases, non-reacting gases. Whatever gas is present, you have to add total mass of that, total mass of the gas divided by total number of moles. You can see, you can memorize this easily. Number of moles equals to what? Mass by molecular mass. So M average is this, so number of moles will come this side, M average will be here. So mass by molecular mass is the number of moles. Okay, this is the formula we have for M average. Now for this particular thing, if I write down the formula you'll get is this. M average is equals to, I have taken 3 non-reacting gases and their mass is M1, M2 and M3, and their respective number of moles is N1 plus N2 and N3. Just a second, Bharat, just a second, I'll go. Do this. Okay. So further, we can just simplify this expression, and we can write M1 plus M2 plus M3 divided by the number of moles is M1 by molecular mass plus M2 by molecular mass plus M3 by molecular mass. This is the formula of M average. Okay. Understood? Finished? So based on this concept, the two things that we have discussed, vapor density and average molecular mass, based on this, we'll solve a question, but that question we'll see after the break. Okay. So take a break. We'll be back at 6:25. We'll be back at 6:25. Take a break. Hello. Can you hear me?
Yes, sir.
Yeah. Okay. Let's do a problem on this. Okay. So what we have discussed vapor density and average molecular mass, correct? Write down this question. If the vapor density of a mixture of NO2 and N2O4 is the vapor density of a mixture of NO2 and N2O4 is 34.5 is 34.5, then calculate the composition in mole percent and mass percent. Calculate the composition in mole percent and mass percent. Try this. Then, what is the answer you're getting? Anyone? What happened? You want any hint? See, in this question, you need to find out the mole and mass percent, correct? Means what? We need to find out the number of moles of NO2 and N2O4. Then we can find out the percentage mole composition, right? What we have only one thing, and that is vapor density. What we can find out from vapor density? What we can find out from vapor density? We can find out the molecular mass of this mixture, right? So what is the molecular mass of this mixture? That will be 2 into vapor density, and that is 69 gram of the mixture. Okay. Now you see, if I write down the formula of this, M average formula, if I write down, that will be total mass by total number of moles. Let's suppose we have to find out mole percent. Since we have to find out in mole percent, so what I'll do, I'll assume the number of moles of this is n. So this will be 100 minus n. Okay. Then we'll write down the formula of m average, which is equals to this, nothing but this, is total mass. Total mass means mass of NO2 plus mass of N2O4. This is mass of NO2 plus mass of N2O4 divided by total number of moles. What is the total number of moles we have? What is the total number of moles? Total number of moles is 100, so 100. Now this mass, because you know the molecular mass of NO2 and molecular mass of N2O4. This mass you convert into number of moles with the help of molecular mass of the two gases, right? Convert this into number of moles, convert this into number of moles. You already know this value, that is 69, and you solve the equation, you'll get the answer. Clear? Got it? Did you understand this relation? It's fine. Did you understand this relation till here? No? Okay. See, what I have done, I have taken the reference of this formula. See this. This formula I have taken over there. Total mass means mass of NO2 plus mass of N2O4 divided by total number of moles. M average is 2 into the vapor density. Correct? That's what I wrote over here. You see this. Mass of NO2 plus mass of N2O4 divided by total number of moles. This is equal to M average. M average is 69. Now you have mass of NO2. So mass of NO2, what you can write? Mass of NO2 is equals to number of moles of NO2 into molecular mass of NO2. Molecular mass of NO2 is 46. Similarly, the mass of N2O4 is equals to the number of moles of N2O4 into molecular mass of N2O4 is 92. Why it is 100? Madhav, if you don't want to take it as 100, you can take whatever you want, right? But in the last, you have to convert this into 100 only, because we need to find out percentage. So whatever you get out of 100, what should be the value? That is the percentage composition, correct? So since we have to find out of 100 only, so what I have assumed the total number of moles is 100 moles. Initially only I have assumed. Out of 100, if this is n, so this will be 100 minus n. So whatever the value of n you will get, that will be the mole percentage of NO2. Clear? Anurag, tell me. Then you wait for some time, I'll do this. Let others also try. What is your doubt? Tell me your doubt. It's not molecular mass of molecular mass of the mixture. That is the that is the concept of vapor density. Vapor density gives you the average molecular mass of the mixture, 2 into VD. That's why VD is given in the question. Yes, this is, I have written it gas over here, but it is the average value. That is what the formula, the last formula you see. What we have taken, total mass divided by total number of moles. That gives you the M average of it. So you got 50 mole percent, right? All of you. And then mass percentage, this is the first case. Now mass percentage, if you have to find out, So it's the same thing we'll do for mass. You'll assume the total number of mass, sorry, total mass, that is 100. Out of 100, m is NO2. So 100 minus m is N2O4. Then again you use the same formula and get the answer. I will do this. I will do this. You check your calculation, Pranav. Mole percentage, you'll get 50%. To check your calculation, I have done everything here. Just you need to solve this. Right? Check your calculation, you'll get 50%. For mass percentage, what we have to do, like you have assumed number of moles, similarly, you assume number of, the mass total. Total mass, if it is 100, so out of 100, m is NO2, so 100 minus m is N2O4. Then again, you use the same formula, m average, substitute the value, you will get the answer. Okay, I'll do this. Did you get mole percentage, all of you? Wait, see. This one, if you substitute this as 69, we'll get 6900 is equals to molecular mass of N2 is 46 into the number of moles of NO2 plus 92 into the number of moles of N2O4. Now it is 46 N NO2, or if I take it as, I have taken it as N, so I'll write down here N only, plus 92 into 100 minus N. So when you solve this, you'll get 92 minus this, so it will get 46N is equals to 2300. So now N is 50. N is 50 means mole percent of NO2. Mole percent of NO2 is 50 and mole percent of N2O4 is 50. It's clear? In this condition, yes, equal molecules of NO2 and N2O4. Okay. Rehan has got the mass percentage also, that's right. Yes. So this is the first part of this question, the mole percent. Okay, that is 50% here. Now you see the next part we have where you have to find out the mass percent. So what I assume, we have N2 and N2O4 and total mass I have assumed 100 gram. If this is M, then this will be 100 minus M. So what we can write, M average is equals to total mass is 100, number of moles of NO2 is mass divided by its molecular mass 46, and its mass divided by its molecular mass, that is 92. Right, so this side is 69, 100 divided by m by 46 plus 100 minus m by 92. We can solve this, you'll get the answer. Is it clear? Any doubt in this? Right. Correct, correct. Answer is correct. But you see, I won't suggest you to do this question by this method here, because in this you have some calculation. What I'm suggesting you see, since you have calculated the mole percent, then the percentage mole of NO2 is equals to the percentage mole of N2O4. So if you see this, whatever mass of NO2 you have here, right? So its moles will be m by 46, and this mass you see it is 92. So molecular mass of N2O4 is exactly double of the molecular mass of NO2. Yes or no? Reply. Molecular mass of NO2 is exactly double to that of NO2. So in order to have the same mole percent, right? In order to have the same mole percent, what we can say? The mass of N2O4 should be twice to that of NO2. Yes or no? Suppose it is m, so m by 46 is the mole. So the mass of N2O4 should be twice of the mass of NO2, so that the ratio is again m by 46. Clear? Did you get it? Tell me, guys. Right? So basically we need to find out the mass percent, and we have the mass ratio of both. One is m, so other one is 2m. Mass ratio is 1 by 2. So what is the percentage? The percentage of NO2 will be what? Percentage mass of NO2 will be, its mass is m, so this is m plus 2m, the ratio into 100. So that will be 100 by 3, which is nothing but 33.3%. Yes. So after finding mole percent, you can directly do this. That's what I said, that since you have calculated mole and you know the mole percentage is equal, so directly you can do this. Percentage mass of N2O4 is what? 100 minus this, 66.7%. Yes, so whenever you get this kind of question, so you always take care of the molar mass ratio of the gas present. If it is like this 1 by 2 or 1 by 3, something like that, if you have, then you can directly do this kind of questions. You can think about it. But if the ratio is not like this, okay, then obviously you have to go by this method. Then this is the method we have process. But since we have percentage mole is equal, you can directly do this. Clear? No doubt? Okay, can I move on? Try this question. These three questions you try. Per mole calculation you have to do. Means the atomic mass is what? Mass of 1 mole, right? Means that is the mass per gram we have. Yes. You know what is the atomic mass of Fe ion? Atomic mass of ion is 56. 56. Okay. Closest value you have to find out. Okay. You won't get the exact answer, but you have to choose the closest option. Thirtieth one is B. Shashwat is getting. 31st is B. Yes, if you got 1217, then the approximate answer will be option D. Closest one is D, so answer will be D. Okay. 30th one. A compound has hemoglobin-like structure. It has one Fe. Only one Fe atom is there, right? And contains 4.6% of Fe. Okay, means what? We have 4.6 gram Fe in 100 gram of that sample. 100 gram of that sample. Okay. And since one Fe is there, it means the total mass of Fe in that sample, in the original sample, should be 56. So for 1 gram, the mass is what of the sample should be this. So for 56 gram, which is the atomic mass of Fe, the mass of sample should be this, which you will get 1217 gram per mole. So approximately the answer is 1200. Why we have taken this? Because this is the atomic mass of Fe. Okay. 31st. The maximum number of molecules present in, okay. So maximum number of molecules means what? We can directly compare the number of moles. The one which has more number of moles will have more number of molecules, right? So obviously 15 liter of H2, see here 15 liter of H2 must have more number of moles than 5. That will be thrice of that of N2. So N2 is not possible for sure, right? Here we have 15 liter. So 0.5 number of moles, if you find out here, it is 15 by 22.4. Here the number of moles is what? 0.5 divided by 2. So that would be 5 by 20 moles. And here the number of moles will be 10 divided by 32. Correct? Now we need to compare this 15 by this, 5 by this, and this. Okay. So what we'll do, because you don't have to divide and find out the value of this and compare. What I'll do, the common thing of this is 10, 5, and 15 is 60 we can take, right? So if I multiply this ratio by 4 in the numerator and denominator, we'll get 60 by something, 89.6. Here we get 12 if you multiply. So 60 divided by 240. 6 divided by 192. So which one is the highest one? The highest one is 15 liter of H2. Hence answer is this. More number of moles, more molecules. N2 is heavier than H2. That is because N2 has more number of protons. Right? But the number of molecules in that volume, that you need to find out. Did you get it? So keep this in mind. See what I have done over here. I have not calculated this. You can divide and find out the answer in fraction, but that is not required. You don't have to find out the value. You just need to compare this. So I have made the numerator common, and depending upon the denominator, we can compare, right? So minimum denominator is here. Hence this value is maximum. Hence maximum number of moles. Volume you can compare when you have this STP. Here the condition is not at STP. So how can you find out volume? Okay, so mass is given. Then what we can do with the mass? That's what I'm asking. With mass, how do you find out volume? Guess what? You are taking it at STP, but STP condition is given only for A and B. C and D you cannot assume at STP. It is not given there. Understood? No, you see, the method is not right because that volume, number of moles is volume divided by the 22.4 liter. It is only defined at STP. So maybe you are getting correct answer in this one, but in other question with other data, you will get the wrong answer, possibly. Right? You need to find out number of moles, and for this you cannot say it is half mole, so volume you can find out. That you cannot say, because moles and volume relation is true when we have the condition at STP. Okay, like this, if you take the number of moles, we can say it is the amount, right? But there are other factors also, gaseous species, how they occupy the volume, available volume. Okay, so I would suggest you that you can get answer if you find out the number of moles, because volume and moles you have said it is directly proportional. But then again, you are assuming constant temperature and pressure. No, you cannot do that. You never know what is the condition for this hydrogen we have. What is pressure and temperature here? It's not given. What is the pressure and temperature here? It's not given. Then you cannot take it at STP because it's not given. And pressure, temperature has a role. So for this two, the last two, C and D, you cannot compare volume, and more volume, more number of moles, you cannot say. No, how? You see, you're not getting it. PV is equals to nRT we have, no? So volume, whatever volume you are occupied, depends upon the pressure and temperature. So the volume occupied by the gas, it depends upon what is the pressure and temperature you are taking there. If it is same, then it's fine. But since it is not mentioned, so that is not the correct way. You may get the answer coincidentally, that's not a big deal, but that is not the correct way to do it. No, if it is not given, you cannot assume that. If it is not given, like you see here, it is given, here you cannot assume that. Okay, so don't do that. Fine. 31st, 29th. What volume of hydrogen gas at 273 Kelvin and 1 atmospheric pressure will be consumed in obtaining this gram of elemental boron? What is the reaction here? Could you tell me? What is the formula of boron trichloride? BCl3. Okay, so you are getting 67.2. Okay, I'll see that. So what is the reaction we have? BCl3 plus reduction. Reduction means hydrogen, by hydrogen is given. So it forms boron plus HCl. Could you tell me the balanced chemical reaction? 2326, is it? 2326. Okay, chalo, 2326. 2326. What is this 2326? These are stoichiometric coefficient, correct? These are stoichiometric coefficient. Okay, right, stoichiometric coefficient. And this means what? 2 moles of BCl3 combines with 3 moles of H2 gives 2 moles of boron and 6 moles of HCl. What we need to find out? Volume of H2 hydrogen gas at this pressure will be consumed in obtaining this gram of elemental boron. Okay, so 21.6 gram of boron is equals to what mole? Number of moles of boron is equals to 21.6 divided by what is the atomic mass of boron? 10.8 is the exact value. 11 also we can consider. Yes. So it is 2, right? 2 moles of boron. Now you see for 2 moles of boron, what is a mole of H2 required? 3 moles. So number of moles of H2 required for this is 3 mole. Right? So 3 mole, and the condition you see, it is given STP 273 and 1 atmospheric. It is STP, right? So 1 mole occupy 22.4. So 3 mole occupy 3 into 22.4. So it is 67.2 liter. The answer is B. No doubt. All of you understood this. There's no doubt, guys. Question number 30 is nothing. You see, you have a sample actually. You see, understand this. You have a sample. We don't know about this sample, what sample it is. That is not given. But what is given? That in this sample, we have one iron atom. There's only one iron atom present, one Fe, because it is given hemoglobin-like structure has one Fe, only one Fe present, right? So we need to find out the approximate molecular mass. Means what? If you take one molecule of this compound, in that molecule, we have only one Fe present. And if only one Fe present into that, it means the mass of Fe should be 56 in that sample. So we need to find out corresponding to this value, 56 gram of Fe, what is the mass of this sample? That is what we need to find out, the molecular mass. Did you understand the question, Himanshu? Why 56 I have taken? Because it says only one Fe. If it is 10 Fe, then I would have taken 56 into 10. And corresponding to that, we'll find out the value of it. So 56 gram of Fe present in the sample. And with this mass, what should be the mass of the sample? That we need to find out. Now the question is what? It contains 4.6% of Fe. Means if mass of iron is 46 gram, right? It's the sample, the mass of the sample is 100 gram. Percentage means this only. So what is the mass of the sample if the mass of iron is 56? Because that is what we need to find out. So 4.6 is 100, 1 is 100 by this, 56 is this, which is this. Correct? Okay. Now, you see this question that we have done the last one, where we have chemical reactions and we have to find out the mole ratio, that these many moles reacts with this mole of this particular element or compound and gives this mole of compound. So if this kind of molar ratio calculation you have to do, this we'll do under the concept, and this we study under stoichiometry of chemical reactions. Right? Again, the next topic we are going to see. Stoichiometry is what? It is the in this particular topic, we are going to study about chemical reactions and quantitative analysis of chemical reaction, right? We'll do the quantitative analysis of chemical reaction, means what is the amount of product forms, like that, okay? Quantitative analysis of chemical reaction. When we talk about a chemical reaction, okay, we have two types of chemical reaction, right? And that is balanced chemical reaction, and unbalanced chemical reaction. Okay. In balanced chemical reaction, what happens? Number of atoms constant, both sides, conserved, we can say. Number of atoms, not conserved, constant. Number of atoms are constant, both sides of the reaction. Right? Both sides. Means number of atoms on the reactant side is equals to the number of atoms on the product side. Similarly here, number of atoms are not constant to this one. It is not balanced. Okay. Now, for example, you see, if I write down this reaction, let us understand this with the help of this example. N2 plus H2 gives NH3. Right? N2 gas state, if you do not write, it's fine. Okay, we are not discussing with respect to this state of this species. Okay. Could you balance this reaction? What is the value? Tell me. 0. It's not 0, it's 1. 132, correct? So this is the reaction we have. We have 3 moles of this and 2 moles of this. Again, this 132 are the one generally we do not write, but I'm writing it down to make you understand. 132. So what we can say from this relation, 1 mole of N2 reacts with 3 mole of N2 and gives 2 moles of NH3. Right? So you see, from this relation, what we can write, 1 mole of N2 reacts with 3 mole of H2 and gives 2 moles of NH3. Correct? Could you tell me, if I take 5 moles of N2 and 15 moles of O2, what is the amount of NH3 forms? What is the amount of NH3 forms? 10. Good. 10 moles of NH3 forms. Okay. And how do we do that? We can say 1 mole gives 2. So 5 mole gives 10. Right? 3 moles of H2. 3 moles of H2 gives 2 moles of NH3. So 1 mole gives 2 by 3 moles of NH3. So how many moles of H2 we have taken? 15. So 15 moles gives 2 by 3 into 15 moles of NH3, which is 10. So point I'm trying to make is what? N2 and H2 both gives equal moles of NH3 in this case. Yes or no? Quickly, tell me. Both N2 and H2 gives equal mole of NH3 in this case. Yes? Correct. Now you take this example. Suppose I have 5 moles of N2 and 10 moles of H2. Could you tell me the number of moles of NH3 forms here? No. Acha, you want to make it 9. Chalo, I'll make it 9. Let's do it 9. The calculation will be easy. No? Chalo, 9. 6 moles. Why 6 moles? Because see, if I talk about the number of moles of NH2, tell me, answer me this. Whatever I'm asking. Number of moles of NH3 with respect to N2. What is the answer we get? Number of moles of NH3 with respect to N2. What is the answer we get? 10. But the number of moles of NH3 with respect to H2. What is the answer we get? 6 moles, correct? So now you see here, the two reactant gives different amount of product, correct? Different amount of product, okay? Why we are getting different value here? Because given number of moles is not in the ratio of their respective stoichiometric coefficient, right? If the given number of moles is in the ratio of their respective stoichiometric coefficient, then the amount of product will be same with respect to both reactant. Wait. Let me just let me explain this. What I'm trying to explain, that if the given number of moles, like in the second case, is in the ratio of the respective stoichiometric coefficient, because you see the ratio is 1:3, 515, 1:3. If the ratio is not maintained, then the two reactant molecules gives you different amount of product. And in this case, the third case here we have, in this case, the reaction is incomplete. The reaction is incomplete because all the reactant molecule is not converting into product. See what I said, Arnav, here, that if you take this reaction, 1 and 3 moles if we take, then we'll get 2 moles of NH3. 5 and 50 moles if you take, we'll get 10 moles of NH3. But if you take 5 and 9 moles of this, then the amount of product with respect to these two reactants will be different. In these two cases, it is same. Whether you take N2 or H2 for the calculation of this, you'll get the same amount of product. But in this case, the amount is different, right? Why it is different? Because the number of moles that we have taken here, 5 and 9, is not in the ratio of the respective stoichiometric coefficient. That's why it is incomplete reaction, and the number of moles of product will be different with respect to the two reactants. So in this case, when the reaction is incomplete, right, or the given number of moles is not in the ratio of their stoichiometric coefficient, in this case, we use one concept to solve this question. Okay, and that concept is what some of you have rightly said few minutes back, that the limiting factor is, some of you said, right? Limiting factor, right? So in this case, when the reaction is incomplete, we use the concept of limiting reagent to solve this question, to find out the amount of product forms. Limiting reagent concept we use. Okay, so here when the balanced chemical reaction is given, we'll use the concept of limiting reagent. LR is the limiting reagent to solve the question, right? When balanced reaction is not given, then we use principle of atomic conservation. Principle of atomic conservation. to solve the question, right? POAC in short we call it as. So POAC will use when unbalanced chemical reaction is there and we are not able to balance the chemical reaction. Okay. Concept of limiting reagent we use when balanced chemical reaction is there. If balanced chemical reaction is not there, then chemical reaction is given and we can balance this easily. Right. So if you have balanced chemical reaction with you, you can directly apply the concept of limiting reagent. What is required for limiting reagent? Like I said, balanced chemical reaction is required plus the initial number of moles must be given. Okay, that is the condition. Initial moles must be given of the reactant molecule. If it is not given, we cannot use this. Yes, it is. Suppose you will have like you are extracting iron from its ore. It will give like this. Iron is extracting from its ore. Then you cannot write down the reaction. Okay, you cannot memorize those reactions, and there are many reactions into that. Okay, so those kind of we'll discuss question. You'll understand this. Okay, so concept of limiting reagent. Initial moles must be given. When we have to apply POAC, then initial mole will not be given. We can assume and then we can apply. Okay. So if anyways, if initial moles is not given, reaction is given, then you have to assume the number of moles and then you have to apply POAC to solve the questions. One by one, we'll discuss both. Okay. But first you should understand what is limiting reagent and how do we do questions for this. Did you understand limiting reagent concept? Right? So limiting reagent is what? It is one of the reactant molecule, okay, that consumes completely to produce the minimum amount of product. What is that? 3 plus 9 gives 6. Yeah, for this one, the answer is this. 6 moles of this will get. 6 moles of this will get. Okay. But limiting reagent, first of all, write down the definition. Limiting reagent, it is the reactant molecule. It is one of the reactant molecule which gets consumed completely. Yes, correct. It is one of the limiting reagent which gets consumed completely to produce minimum amount of product. Okay. Step to find out limiting reagent. Write down steps to find out LR, limiting reagent. Okay. First step is balance the chemical reaction. Balance the chemical reaction. Balance the chemical reaction. Next. Limiting reagent, it is the reactant molecule which gets consumed completely to give minimum amount of product. Okay, consumes completely to give minimum amount of product. Steps, the first step is to balance the chemical reaction. Second step, write down, divide the given number of moles. Divide the given number of moles of the reactant molecule by their respective stoichiometric coefficient. By their respective stoichiometric coefficient. Okay. Next, third and the last point, the reactant molecule which provides the written like this, the reactant molecule which has the lowest ratio is the limiting reagent. Second point I said, divide the given number of moles of the reactant molecules by their stoichiometric coefficient. Third point, the reactant molecule which has the least value, which has the least ratio, write down, which has the least ratio is the limiting reagent, is the limiting reagent. So let us take the same example and understand this. N2 plus H2 gives NH3, it is given. And we have, and the number of moles that is given here is, we have 5 moles of N2 and 9 moles of H2. We need to find out what is the moles of NH3 forms. And since once you find out the number of moles, we can find out mass also, right? STP it is given. They may ask you the number of the volume that obtains. Okay, anything they can ask you. Now this is the question. First of all, we'll balance the reaction. So when you balance the reaction, you'll get N2 plus 3H2 gives 2NH3. So this 1, 3, and 2 are the stoichiometric coefficient. Obviously, you see the molar ratio of N2 and H2, the reactant molecule is 1:3, and here it is not 1:3. So if it is not in the same ratio of their number of moles, it means the reaction is incomplete reaction. Incomplete reaction means there will be some unreacted reactant present, right? Residue will be there in the reaction. In case of incomplete reaction, one of the reactant molecule decides the amount of product that has been formed, right? Because both gives different amount of product. N2 will give 10 mole of this will give 6 moles of this. So the one which is the limiting reagent, that only defines the amount of product forms, okay? And once you get the limiting reagent, we'll do all calculation based on limiting reagent. You don't have to do anything with the other reactant molecule, okay? Now to find out the limiting reagent, what we do, the given number of moles, 5, should be divided by their stoichiometric coefficient. 9 should be divided by their stoichiometric coefficient. This is 5 and this is 3. Since this is the smaller value, right? Hence, this is the limiting reagent. The one which gives the smaller value is the limiting reagent, because this 3 is smaller than 5. H2 is the limiting reagent. Once you get the limiting reagent, right, then the calculation will be based on this limiting reagent. So the amount of NH3 forms in this, NH3 forms is equals to 3 moles gives 2. So 1 moles gives 2 by 3. But how many moles H2 we are taking? 9 moles. Hence it is 6 moles of H2 forms, which you have already done. But I hope you understood the concept of this. Why we are saying that it gives the minimum product, minimum amount of product, because you see when the reaction takes place, right? So 3 moles combines with 1 mole of nitrogen. So 9 mole combines with, I'm coming to this point, Mr. Reyes, just a second, okay? 3 mole combines with 1 mole of nitrogen. So this 9 mole combines with 3 mole of nitrogen. So here when reaction takes place, out of 5 moles, 3 moles reacted. All these 3 moles has been reacted, right? And 6 moles of this NH3 forms. So in the reaction vessel, if you see where this reaction is taking place, when the reaction gets over, we have NH3 present and N2 present into this, okay? The number of moles of N2 which is left here is 2 moles of N2 is still there in the reaction. NH3 that forms here is what? Is 6 moles of NH3. So this 6 moles depends upon this H2. Further, if you add hydrogen into this H2, if you add, again the reaction proceeds, you'll get more amount of NH3 into it. So the amount of NH3, it is defined with respect to H2. And this is the minimum possible amount we have over here. That's why the definition of limiting reagent is what? It is the reactant molecule which gets consumed completely to give minimum amount of product. Is it clear?
So we can do this another way. Like we can say that 5 moles of N2 require 15 moles of H2 to
Right.
give this much NH3, but then only 9 moles are present. So that's why that is the limiting reagent.
Reagent. That also you can do. This is the simplest reaction. No, you can do it
Yeah.
easily. Okay, but if some complex reaction is there, this method probably help you. Okay, this method. So better, like it's a simple one. You can just you have to take the mole ratio.
And sir, I have one question, sir. If in a complex reaction, if after you divide it by the stoichiometric coefficient, if you get it the same value, like if you get 3
Same
for this one
value,
and
it means, yeah, if it is same value, it means that the reaction is complete. There's no incomplete like residue left. Like the question you are asking, you can try over here. You see this. Here, if you try to find out the limiting reagent, 5 divided by 1, what you will get?
5.
15 divided by 3, what you will get?
5.
5. It means what? It means the reaction is complete.
No, sir, I meant if there are more number of reactants and like out of 3, two have the same value after dividing and one has different.
Correct.
So then what will be the
What about the third one? Third one is more than the other 2.
Yeah.
Then any 2 you can take, both gives you the same amount of product. Both are the limiting.
You can take any 2.
Yes, any one you can take.
Okay.
Any one you can take for the calculation. But yes, third one we cannot take because that is not deciding.
That's not limiting.
Yes. So any one of the 2 is the limiting reagent. Both gives you the same answer.
Yes, sir, thank you.
Clear? One small question we'll discuss onto this and then we'll wind up the session. See this one. We have a reaction X plus Y plus Z and it gives X3 Y5 Z6. This is the reaction given. And like I said, reaction plus their initial number of moles will be given to use the concept of limiting reagent. Okay. So 5 moles of X is given here. 6 moles of Y is given. And 10 moles of Z is given. What you need to find out? You need to find out the limiting reagent plus the number of moles of product formed. Limiting reagent plus the number of moles of product formed. Shashwat, any doubt? Okay. So Pranav is getting Y, the limiting reagent. Is it Y?
So it's X or Z, one of them.
Okay. Let's do this. So first of all, what we need to do, we need to balance the reaction. So we'll have 3X, we'll have 5Y, we'll have 6Z. Okay. So we'll divide 5 by 3, 6 by 5, and 10 by 6. So here the least value is what? The least value is 6 by 5. 6 by 5. And hence, this is the limiting reagent. Why? These two, you see the same case you have that you are asking. 5 by 3, 5 by 3, same. So X and Z will have the same value, but Y is the least. So this is the limiting reagent. Right? Now, when we get the limiting reagent, then we have to do the calculation based on limiting reagent, not these two. So we can ignore this. Just you have to focus on this. So what we can say, 5 moles gives 1 mole of this. So 6 moles gives 5 moles gives 1, so 1 mole gives 1 by 5. 6 moles gives 6 by 5 of this. 1.2 moles of the product we get. Clear? Any doubt? See, how do you compare these ratios here? I'll tell you one method here to compare these ratios, okay? So you don't have to find out the fraction value of this. Suppose you have to compare 5 by 3 and 6 by 5. Suppose you have to compare this. So what you do, you just cross multiply this. I'll tell you how. What you do, you cross multiply this. What are you getting? 5 into 5, 6 into 3, 18. So this is lesser than this. It means this ratio is lesser than this. Lower value is this. If you want to compare this one, suppose some 4 by 3 is there, then 5 by 4 is there. Suppose you want to compare this. 4 into 4, 16. 5 into 5, 15. This one is less, so this value is bigger than this. Just cross multiply and compare this. Understood? Any doubt, guys? Fine. Okay, guys, so we'll wind up the session here. Okay. There are assignments on Learnist. Okay, you must solve those assignments. Okay, we'll start next class from the questions on limiting reagent. Thank you. Bye-bye. I will share on the group. Wait, I'll show you. Learnist there.